What volume of a 6 molar solution of potassium chromate is needed to give you 23.4 grams of K2CrO4? And this is actually the formula for potassium chromate. This is a problem, looks like, involving molarity. So any question involving molarity will need to use the formula for molarity, which is denoted by big M. Molarity is equal to moles of solute divided by volume of solutions, or moles divided by liters. Now let's analyze this problem and see what information we have to work with. Given to us in this problem is the molarity of the solution. So we have 6.0 molar solution of K2CrO4, and this is the molarity. Also given to us is the mass of potassium chromate, 23.4 grams of K2CrO4, and our unknown, what the problem is asking for, is the volume of solution required to give us this mass. So our unknown is volume of solution. That's our unknown. Now, what information is required? Well, we have the molarity right here. We're looking for volume of solution. This is our unknown, and we need, in order to get that, we need the moles of the solute. We have the grams, but we don't have the moles of solute. So we required is moles of solute. As soon as we get that, then we can go ahead and plug these in and then calculate the volume of the solution. So here is the plan for coming up with this answer. Here's our plan. First thing we're going to do is we're going to convert these grams to moles to get the moles of solute, converting grams to moles. And then once we do that, we can just go ahead and plug in the information into the equation in order to isolate the unknown variable. So that's our plan for moving forward with this type of problem. So let's start on this by tackling the first step in our plan, which is to convert from grams to moles. In order to do that, we are actually going to need some information. Here's required information in order to get that: the molar mass of potassium chromate. So the molar mass of K2CrO4, we need that in order to even do this step. So how do we find the molar mass? Well, we find the molar mass of each of the elements in the compound, and then we'll add them all up. And we do that by going to our periodic table. So looking at a periodic table, potassium, molar mass of potassium is 39. The molar mass of chromium is 52. The molar mass of oxygen is 16. And so if we go ahead and put that in there, our potassium molar mass is 39. We have 2 of those. Our chromium is 52. We only have 1 of those. Our oxygen is 16. We have 4 of those. And now we just continue doing multiplying this out. 78, 52, and 16 times 4 is 64. Add them all up, and we get 194 grams per mole. And this right here is the molar mass of our potassium chromate. And now that we have this, now that we have what's required, check that off, we can go ahead and convert from grams to moles. So let's go ahead and take our 23.4 grams potassium chromate, 23.4 grams K2CrO4 over 1 This is the setup to set up the problem. And now we have grams in the numerator. We want to cancel out these grams, so we want to have to go and put our grams in the denominator over here. So that's 194 grams of potassium chromate, and 1 mole is equivalent to that right here. And now that I have my grams in the numerator and in the denominator, when these fractions multiply, my grams is going to cancel out. I'm only going to be left with moles, which is what I wanted to convert grams to moles. 23.4 times 1 mole of K2CrO4 is going to be 23.4 mole of K2CrO4 over, and then 1 times 194 is 194, and you go ahead and put that in the calculator and divide, and you will get 0.1206 moles of potassium chromate. And there's that. We want to circle that because now this is another piece of information that we need, and this is actually required. Moles of the solute is equal to 0.1206 moles of potassium chromate. And so now that we have the required information, the number of moles, we can move on to the second step in our plan. And the second step in our plan is to go ahead and plug in the given information into the equation in order to isolate the unknown variable. So here's what that's going to look like. First, let's bring down our equation for molarity, which is that, and molarity, moles divided by volume, and we just found moles, and we were given molarity. So our molarity is 6. It was 6 that was given to us, equals moles of solute, we just found that, 0.1206, and volume we do not know. So we're going to put that down there like that, and this is our volume of solution. Now we're just going to do a little bit of algebra to go ahead and then isolate this variable and solve. So let's get it out of the denominator first. Times VOL times VOL, and that way it'll cancel. So volume times 6 equals 0.1206, and now divide both sides by 6, and once you do that, then the volume will equal 0.02 liters of potassium chromate. And this is our final answer, so we'll box that.